Okay, today we want to have a look at equilibrium of bodies in fluids. Yes, the previous video we had a look at equilibrium of forces acting on a solid body. But in this video, we are looking at a solid body submerged in a fluid. What is a fluid? A fluid is any substance which is capable of flowing. That means it can flow when you pour it. And a fluid can be either liquid or gas. So, water, petrol, oil, kerosene, those are fluid under liquid. Air, nitrogen, or oxygen, chlorine, those are gases. And they are also fluid. So when we now say a body is submerged, partially or fully, what does that mean? It means when we dip a body inside a liquid or gas, such that the whole of the body is inside that fluid, or part of the body is inside the fluid while the remaining part is outside. Whichever way, we will say it is submerged. But fully submerged means the whole body is inside that fluid. Partially submerged means part of the body is inside the fluid while the remaining part is outside. And the one outside we will say is in air because it's exposed to the atmosphere. Now, whenever a body is submerged, either partially or fully, there are two forces acting on it. One, the weight of the body itself. That body that we dip inside the fluid, its own weight, which is always acting downward. And two, another force that the fluid, either liquid or gas, exert on that body, which is called upthrust. So that force is called upthrust or buoyant force. So that force always acts upward. That means it counters the weight of the body. Now, these two forces are what we are going to discuss under Archimedes' principle. All right, as I have already explained, upthrust is an upward force. And this force is exerted by the liquid or gas, depending on the fluid we use, on that body that is immersed in it. So this upthrust depends on the following: the volume of the object that is immersed, and also the density of the fluid itself. But you need to take note, that means if you want to find upthrust, you can find it by saying volume of object submerged times density of fluid times acceleration of gravity, g. This one is a constant. Acceleration of gravity is constant. Now, as stated in Archimedes' principle, that when a body is partially or fully immersed in a fluid, when you immerse something, you submerge it, it experiences an upthrust, which is equal to the weight of fluid displaced. So we need to pay attention to this part. Upthrust equal to the weight of fluid displaced. That means it's not referring to the weight of the whole fluid. But you know, when you put an object in a fluid, the level of the fluid will come up. So the amount with which it comes up, if you can collect it and weigh it, that is the weight of the fluid displaced. So don't mistaken it for the whole fluid. It's only the part of the fluid that is displaced that we will calculate its weight. And whatever the weight of that is the upthrust. So that means that, like the formula I've already written here is what I'm repeating here. But there's something I want to add to it. This volume of the object immersed is the same thing as the volume of the fluid displaced. Take note of that. I will write that on the board now. So, according to this note, if we put a whole body, the whole body, and we put it inside the fluid, such that no part of it comes out of the fluid, then that means the volume of the fluid displaced will be also the same thing as the whole volume of that object. But if, let's say, 1/4 of that body is immersed, that one is partially immersed now. It is 1/4 of the volume of that body that will be the volume of the fluid displaced. So you need this knowledge in the calculation coming after this stage. So take note of that.